Hello students, here I am discussing one specific topic that is from aromatic compounds. So it is regarding the aromatic electrophilic substitution reactions. So you know that benzene is involved in a aromatic alcohol substitution reaction. When benzene has one substituent, so that substituent may be orthopara directing group or meta directing group, and that substituent may be activate the benzene ring towards cell profile attacking or deactivate the benzene ring towards cell profile attacking. Okay, so generally minus M groups are the deactivating groups. That means electron withdrawing groups are the deactivating groups, and electron donating groups, that means plus M groups are the electron donating groups. Those are the activating groups actually. So here in this case you know that all activating groups are the orthopara directing groups, and all deactivating groups are the meta directing group. For suppose NO2 is a deactivating group, that is a meta directing group. Aldehyde group deactivating group and meta directing group. For suppose OH, NH2, CH3, OCH3, all these are the activating groups, and orthopara directing groups. You know that basic information. Okay, but here and we know very well about the halogen. When benzene attached to the halogen, that deactivate the benzene ring. Okay, for suppose Cl is attached to the benzene, that deactivate the benzene ring. But orthopara directing group, as you know that all electron donating groups, that means activating groups, are the orthopara directing groups, and all electron withdrawing groups, so that means deactivating groups, are the meta directing group. Halogen is a weakly deactivating group by the minus I effect. So by the minus I effect, that withdraw some electron density from the benzene, so that deactivate the benzene ring towards electrophile attacking. So even though it is a deactivating group, it is a orthopara directing group. You know very well this one. Okay, so actually here by the minus I effect, it deactivating the benzene ring, but it is orthopara directing group. Okay, now here how it is explained, that is orthopara directing group. First suppose initially electrophile attacks on the ortho position. Okay, this is the sigma complex actually. Cl, here electron, here hydrogen, and here this carbon carries a positive charge. Okay, and these two pi bonds. Now here if a electrophile attacks at the meta position, in case of the halobenzene, this is the electrophile attacks at the meta position, and this one of course this one carries a positive charge actually. Okay, this one carries a positive charge because here these electrons are transferred to this one. So now here generally there are some two sigma complexes when electrophile attacks at the ortho position and meta position. Which sigma complex is more stable? Generally here formation of the sigma complex is a rate determining step. Why it is called the sigma complex? By the breaking of pi bond, here one new sigma bond is formed. That's why it is called as a sigma complex. Okay, so generally here a sigma complex formation, or you can say that electrophile attacking is a slow step. Okay, it is a rate determining step. If higher the stability of the sigma complex, higher the rate of reaction for the respective compound. Now here in this case it is more stable because this sigma complex is stabilized by the plus M effect of the halogen. Okay, but in this case here the plus M effect of the halogen is not working, just it is involved in a conjugation with two pi bonds. That halogen carbon do not get the positive charge in this case, but here in this case when alkophile attacks at the ortho position, para position, that a halogen attached carbon getting a positive charge here, positive charge here, this one. When alkophile attacks on the para position, this is the sigma complex. It is stabilized by the this pi conjugation, as well as now here this chlorine attached carbon get positive charge. Now it is stabilized by the plus M effect of the halogen as well as the pi bonds conjugation. So here when alkophile attacks at the ortho position, para position, those sigma complex is more stable. But here when alkophile attacks at the meta position, that sigma complex is not stabilized by the plus M effect of the Cl, but it little bit stabilized by the pi conjugation. That means two pi bonds. Here it is stabilized by the two pi bonds as well as stabilized by the plus m effect of the halogen. So here in this case sigma complex is more stable when alkophile attacks at the ortho position and para position. So that's why halogens are the ortho para directing but deactivating by the minus I effect. Okay, and here similarly we can say that this NO group also deactivating group. Okay, how this is a deactivating group? Because of the pi conjugation deactivating group, but because of the lone pair of electrons it is a ortho para directing group. The same story here we can explain. Here also sigma complex is stabilized by the that plus m effect of the lone pair of electrons. When alkophile attacks at the ortho position, here this carbon carries a positive charge. When alkophile attacks at the ortho position or para position, that group attached carbon getting a positive charge. Of course, it may be stabilized by the plus m effect. Here also it is stabilized by the plus m effect. So that plus m effect gives some extra stability. But in case of the when alkophile attacks at the meta position, that plus m effect of this group or any group is not working with that positive charged carbon. Okay, that's it. So here NO also deactivating and ortho para directing group. Here also same story here when benzene attached to the this one, S double bond O R, okay, lone pair. So because of the pi conjugation it is a deactivating group, and because of the lone pair of electrons that sigma complex is stable when alkophile attacks at the ortho and para positions. Okay, and next here a very interesting group. This is for suppose that if the total group is attached to the that benzene, nothing but a cinnamic acid, that is a cinnamic acid. Here the cinnamic acid, because of the pi conjugation, here totally deactivated, so it is a deactivating group, but it is a ortho para directing group. So here how it is a ortho para directing group, here I can explain like this. Here CH double bond CH, C double bond OH. When alkophile attacks at the ortho position, this is the sigma complex. Now here the sigma complex is stabilized by the these two pi bonds conjugation as well as this pi bond conjugation. So this pi bond conjugation gives some extra stability. When alkophile attacks at the meta position, that extra stability from this C double bond C is not available. So positive charge pi bond pi bond. Just it is involved in a conjugation with the two pi bonds, but conjugation is missing with this CH double bond CH. That's why sigma complex is less stable. So finally this cinnamic acid deactivating but ortho para directing group. And similarly CH double bond COH, here also same story, this one, and here also CH double bond CH and CN or CHO, all these are the deactivating groups but ortho para directing groups. Now here also this one, you see this one, when the group is attached to the benzene, that N double bond NH, here because of this pi conjugation that is a deactivating group, but here the lone pair of electrons present on this nitrogen, that sigma complex is stable by the lone pair of electrons when alkophile attacks at the ortho position and para position. Okay, the main key point is when alkophile attacking at the ortho position and para position, that sigma complex getting some extra stability from the plus m effect of the halogens or these groups. Okay, but in this case when alkophile attacks at the meta position, that plus m effect is not working with this positive charge, because this group attached carbon is not getting a positive charge. Okay, here this positive charge is delocalized to this carbon or this carbon. Okay, that is the main key point of this concept actually. So here this is also ortho para directing but deactivating group. Okay, and next here this styrene is a very interesting one here. Actually we thought that styrene is a activating group and ortho para directing. Of course it is ortho para directing, but that group is a deactivating group. Okay, here CH double bond CH2, that accept the electrons towards itself, so like that vinyl group deactivate the benzene ring, but here the sigma complex is stabilized by the extra pi conjugation of the C double bond C when alkophile attacks at the ortho and para position. Okay, that's it. Okay, this point have taken from the one of the standard book, that is oil phenol. Okay, next here, this one also very interestingly, benzyl halide. This benzyl halide also deactivating because of the halogen strong minus I effect. This one deactivate the benzene ring towards electrophilic substitution reaction, but it is orthopara directing group. Why it is orthopara directing group? Here, when electrophile attacks at the ortho position, this plus charge is stabilized by the two hydrogens CH sigma electron. There is nothing but hyperconjugation. Okay. Now here, but CH-COOH is activating group, actually activating and ortho para directing. Okay. A CH2Cl or CH2B or CH2I, these are the deactivating but ortho para directing. Here why CH2OH is activating and ortho para directing, the minus effect of the halogens higher than the oxygen, so here minus effect of the OH is negligible. That's why here this benzene is activated by the hyperconjugation of the two CH bonds. Okay, of course sigma complex is also stabilized by the hyperconjugation effect of the two CH bonds, that is. So here finally these are the electron, that means ortho para directing groups, but deactivate the benzene ring. For suppose here we can see this question, this group. Okay, yes, double bond O, here double bond O, this is alkyl group. Here no lone pair of electrons, so it is a deactivating as well as a meta directing group. Okay, that's it. And next, as well as this benzene when attached to the methyl, here methyl, this one carries a positive charge. Even lone pair of electrons are present, it is a very strongly minus I group, because positive charged groups are the very strong minus I groups. Deactivate the benzene ring as well as meta directing group it is. Okay, that is because it is a very electron deficient group because that carries a positive charge. Okay, that's it. Okay, so thank you for watching. For more videos like this which are very useful for JEE Advanced, CSR Gate and IIT Job, please subscribe my channel. Thank you.